I think we'll start now. Good morning, everyone who's joined in this webinar. This is the first in the series of two half-day webinars on the broader picture of the sector, power sector. So we already had regional workshops for the state stakeholders jointly with CA. So IRADe jointly with CA organized regional capacity building workshops on rules, regulations, guidelines, standards, which are made which are made mainly by either the Ministry of Power or CA or CRC, but meant largely for the states. Now, to make sure that the states understand the nuances of these regulations so that they can use these efficiently, we organized 5 regional workshops, region-wise, starting with northern region, then eastern, then northeastern, then western, and then southern, starting from July 24 to February 25. And after that, we had a series of 4 webinars, which dealt with topics which many of the states said they want to like to know more about, and which would give a bigger audience to the states, because they can see these or take part in the webinars wherever they are, and they don't have to come forcibly to a place, which is difficult sometimes. So that also the 4 sets of webinars which were held in starting from February end to March, we've conducted those 4 webinars, which range from a number of topics on resource adequacy and power procurement and general network access, then the forecasting of wind and solar, which is now becoming important in view of the large integration of renewables to the grid, and also use of AI, artificial intelligence, in forecasting. So we had people who are experts in their fields presenting these, and of course from CNCRC, the authors of these regulations, and also smart grid, use of smart grid for tackling the issues of integration of renewables to the grid. And after that, we are having a set of 2 webinars now, which are high level webinars, so that everybody gets the big picture. So we start this webinar by chairperson of CA on the vision for the power sector in view of Viksit Bharat 2047. After that, it'll be Dr. Kirit Parekh, who's chairman of IRADe, who will be presenting on technology, the field of technology in the power, use of technology in the power sector. I'll introduce the detailed topics when we come to them. And of course, we are going to have one more half-day webinar where there'll be 2 speakers on 29th of April. So that the confirmation is awaited from Director General of International Solar Alliance, as well as one more speaker. So that will be on 29th. We'll put it on we'll send mails to all the state heads, as we've done earlier, on the details of the topics today, or maximum by tomorrow. So we'll start this high-level webinar. I'll read out a brief CV of Mr. Ghanshyam Prasad, who's presently chairperson of the Central Electricity Authority. He is presently holding the post of chairperson and ex officio secretary to the Government of India, Central Electricity Authority, Ministry of Power, from 15 July 2022. He is also member ex officio of the Central Electricity Regulatory Commission He belongs to the Central Power Engineering Services batch of 1989. Prior to this, he was holding the post of Joint Secretary in the Ministry of Power from 1st June 2020. He has served in the Ministry of Power for around 9 years in various capacities, that is Director OM and Transmission, Chief Engineer OM Transmission and Reforms and Restructuring and Regulatory Compliance Monitoring. He did his graduation from IIT BHU, BTech in Electrical Engineering. He holds an MTech in Energy and Environment Management from IRADe Delhi and also MBA Finance from IGNOU Delhi. He has served for 30 years in the power sector and 3 years in Bokaro Steel Plant SAIL. During 30 years in the power sector, he has worked and contributed in the areas of generation, including renewable energy, transmission, distribution, power market development, trading of power, reforms and restructuring in the power sector, energy efficiency, regulatory commission experience, disaster management in the power sector, data analytics and information management system. A number of measures were taken to reduce the cost of power, ease of doing business, simplification of the procedures for approvals, bringing competition in the power sector, etc. He has also served in Haryana Regulatory Commission for around Electricity Regulatory Commission for around 6 years and brought out new regulations. He also has corporate experience and was Government Nominee Director of Power Grid Corporation of India, Power System Operation Company Limited, POSOCO, which is now called Grid Controller of India, Jammu Kashmir State Power Development Corporation, in Corporation Limited, and presently he's director on the board of Nuclear Power Corporation of India Limited in ex officio capacity. With that, I thank Mr. Prasad for taking out time from his busy schedule in order to get across. So he's got such a vast experience in the power sector that there'll be a lot of value addition to people who listen to this webinar. And he's been deeply involved in framing the vision for the power sector, especially in view of Viksit Bharat 2047. So we'd love to hear from you, Shyamji. I hand over to you. Please carry on.
Thank you, sir, and good morning to everyone. I think the panelists who have joined through webinar and the participants also who have taken out their time to be a part of this webinar. In fact, CA along with IRADe had been working on how to reach to the people in terms of the power sector and also sensitize them what are the things that is happening in the sector. As you all are aware, CA had done some exercise for a scenario for 2047 in terms of the vision of Viksit Bharat, which we had presented on our Golden Jubilee celebrations on 14th of October 2024. And we had mentioned what will be the path under the given today's scenario. That means the present technology which is available, likely future technology which can be made use of in a time frame of 2047, and assuming that the growth of demand also occurs as we have envisaged and slightly more than what is the present trend. If we see that scenario, you'll realize that we have no option but to continue aggressively on the path of renewable energy, and we need to take to see that solar, wind, battery storage system, hydro pump storage, all these elements, and even nuclear, if we concentrate on the non-fossil side of it, needs to be accelerated. And this is what has transpired the policymakers, the planners to see that we move in this particular direction. Particularly, I'll say mention here with respect to hydro, there is a push now, and you must have seen last year we could commission 800 megawatt of hydro, which normally used to be around 60 to 200 or 300 megawatt per year. But at least because of the focus, we could do that. This year, we are again targeting somewhere around 3,000 megawatt of hydro pump storage, which will be a substantial number with respect to the present operating capacity, which is hardly 3.5 gigawatt as of now. Even though the installed capacity is 4.7 gigawatt of hydro pump storage. But this is not the end of the story, because we would like that the hydro pump storage takes a further seat and is accelerated further. And in that endeavor, we have done a number of exercises for hydro to promote hydro pump storage. And the closed loop off-stream type of hydro pump storage is really promising in this direction. Last year, CA had conquered 7.5 gigawatt of hydro pump storage, 6 of them, and they will be fructifying from 26-27 onwards. And these will definitely be on board latest by 29-30. This year, we are trying to, we have already targeted 13 projects of around more than 20 gigawatt of capacity. And maybe if developers are able to bring their DPRs faster, we'll be trying to see that they are also conquered by CA in a faster manner. Idea is to reach to somewhere around 50 to 55 gigawatt by 31-32. Similarly, because we will be not accelerating to that extent in terms of fossil fuel, so we need to look at other alternatives, and that comes in this space of nuclear. So nuclear again, from a meager of around 8.2 gigawatt as of now, we need to take it to 50 gigawatt or 100 gigawatt by 2047, which is the revised expectations of the high of the government. And we have been given that task, that how do you really plan and try to see that 100 gigawatt is achieved by 2047 in terms of nuclear. It's a big task, but definitely we are hopeful that we will be able to chart out this. And for that, task force has also been made, which is being co-chaired by one of the member ENC of CA. And we'll be giving those recommendations to DAE and others, and will jointly Ministry of Power as well as Department of Atomic Energy. Both of them will be working together to see that the dream is realized and more participants comes in the field of nuclear. But since the quantum of solar and wind which will be added in that time frame will be much higher, so we'll have no option but to go for battery energy storage systems as well to bridge the gap. And the quantum will be quite huge in this space as well, because as you have seen in the NEP, National Electricity Plan for Generation, we have pointed out that we'll be requiring somewhere around 74 gigawatt of storage. So whatever we are able to realize through the PSP, the balance will have to be realized through the BESS system. There are various technologies which is there at present, and some are emerging. And particularly going forward, we will have to see that what are the long duration energy storage system options that is going to be made available to the users of the country. CA recently had also issued an advisory saying that at least let's start mandating, or at least using, if not mandate, around 10% of storage along with the RE, so that their deviations can be managed to a larger extent. And whatever is the energy that is there, that can also be used to supply electricity to the consumers during non-solar hours, which is going to be critical as we go along. Because during solar hours, because of the presence of solar, which we get around, say, 55 to 60 gigawatt on any given day, we are able to manage the demand. And even though the load has shifted towards the solar hours, and the peak expected this year itself is around 270 odd gigawatt, which means that during the off-peak or the non-solar hours, it is expected to be somewhere around 250 or 255 gigawatt, which is a challenge definitely, but we'll try to see that we are able to meet with this. So non-solar hours being a challenge, reducing grid inertia is a challenge. So we are also thinking of going for a synchronous condensers, some other measures which can really enhance the reliability and inertia into the system. Could be the grid forming inverters also can be another options. So all these are being made a part of the bidding documents as well as the transmission planning system as well. In order to ensure that the resource adequacies are maintained, we have done that exercise for all the discoms for a time frame of 31, 32 earlier, and we have revised them to 34, 35 now. And as we had mentioned earlier, that it has to be made dynamic so as to capture the latest what is happening into the system. So based on the 24, 25, again, another exercise will be done for 35, 30, 36 time frame. That means next 10 years. So this will be rolling and will be revised every year. Similarly, now this year we have also taken up the exercise of resource adequacy for the transmission. That means intrastate. So far, we had been concentrating mainly on the ISTS from the central side, but seeing the gaps in the ISTS and the intrastate transmission systems, we have decided consciously that we'll be doing a joint exercise with the states to ensure resource adequacy for transmission as well. So we have recently concluded the exercise for Delhi and submitted them to the state and the Ministry of Power to take it forward. Similarly, we are planning to complete most of the exercises by June or July this year, or latest by December 2025. We should have all the intrastate transmission system plans in hand so that the intrastate systems is also strengthened for evacuation of RE and to meet the demand of the state in a reliable manner. So these are some of the plans, and in order to have a reliable grid operation, definitely there are standards, there are regulations which are mandatory to be followed by all the RE developers, all the stakeholders in the systems. There are regulations by CERC. There are rules notified by the Government of India. There are provisions in the Act. So Act, rules, regulations, standards, guidelines, all of these are very, very important to be followed by all the stakeholders religiously. And these webinars are a step in that direction. And I'm really thankful to Krit Parekh sir and his team, and also Pankaj Batraji for initiating this exercise. And we have already concluded the regional level workshops. And today I am told that this is the national level workshop where anybody can participate, whoever have been left out. So our idea was to really educate and to bring to the notice of all these stakeholders who matters in the area of power sector, particularly in terms of the rules, regulations, standards, guidelines, which needs to be followed to maintain healthy grid. And we are able to give reliable supply to the consumers. With that, I'll end, and thank you so much.
Thank you, Ghanshyam Prasad ji, for elaborating on what is planned in the future. Especially the hydro and the pump storage and other types of storage, as well as foray into nuclear. So thank you very much for that vision in view of Viksit Bharat 2047. and of course ensuring power supply and resource adequacy, not only in the generation and transmission, and not only interstate transmission but also intrastate transmission, because they form a continuous flow. They form a continuous line for evacuating power. Are there any questions from anyone of the audience, either in the chat? I don't see anything on the chat or the Q&A, but if somebody wants to ask any questions, they can ask now, can raise their hand and ask. So I just also, I'll ask a question about, is there a plan for small modular reactors on, that's nuclear reactors on a large scale basis, or because many industries are thinking of going in for that, but is there a plan, a national plan for facilitating that, and also the supply chain for that?
It is definitely in the plan, sir. As I mentioned that earlier we were targeting around 50 gigawatt by 2047, which would have been achieved with the conventional nuclear technology which India has. But the moment we got the revised target from Honorable Prime Minister to go for, and the announcement in the budget itself, stating that we need to target 100 gigawatt by 2047. So this has led us to rethink the entire plan. And of course, in that kitty, now the SMRs and Bharat small reactors, these are slightly two different things. Bharat small reactor is of 200 megawatt size, which is easily promised, and probably it will be, since the design exercise is available to India, so that will be rolled out first. And after that, SMRs can also be rolled out, and we are trying to, and I'm told that some of the private companies are also interested in it, and particularly those industries which want to go green and decarbonize themselves earlier, they would like to have it also in the captive mode as well. That will require certain changes in the relevant act and rules, which is under examinations. And as I mentioned to you, that there is a joint committee, the co-chair of that committee is also being led by CA member ENC. So that report is almost final, and hopefully that we'll have some roadmap on that as well. We had a joint meeting recently chaired by our Honorable Minister of Power, wherein NPCIL, DAE, BARC, MOP, NTPC, etc. were invited jointly, so that how do we really take the entire exercise forward in a joint manner. So some suggestions had come there as well. So we are working on it, and hopefully by end of this year, we should have a clear-cut plans to take nuclear forward. Thank you.
Right. Thank you, I think, for that very informative vision which is there, and you being at the heart of planning in the power sector, right from the ministry to CA. I think it's a very good overview of what is planned in the power sector, and of course there's a big plan for closed loop pump storage, which is there, but I guess maybe the states would have to facilitate this, because many of these are the private parties are tied up with the states. So I think the state stakeholders here also were there quite a lot. We would request everyone to facilitate these, because long duration storage, as mentioned by Chairperson C, is very important when you have a huge amount of solar and wind. So is there any follow-up with the states on facilitating this long duration storage, the closed loop pump storage? Or would you like to give them a message to do this? Because we've got a large target And I hope that we are able to fulfill it.
Sir, I think states are on board. There are most of these states, and because everybody has now realized that it is challenging to meet the demand of the state during the non-solar hours, that is the evening hours. So every state is have been onboarded, and those which are not having PSPs, they are going for BESS. But as of now, to just give you a numbers, as I mentioned, that this year we are planning to conquer around 13 projects of around 20, more than 20 gigawatt. There are roughly 66 gigawatt worth of project which is under survey and investigations, and all these we would like to get it fast tracked. All the organizations, whether the appraising organizations, particularly CWC, GSI, CSMRS, they are all onboarded, and we are having a coordination meeting every month now, wherein member DNR from CWC, GSI, and others, they also participate, and we try to clear any bottlenecks, whatever is there. In this space, we are also trying to, besides whatever have already happened, we are also trying to onboard some of the institutes of national importance, and we had recently had a expression of interest. Those institutes who would like to be part of this particular exercise of preparation of DPR, examinations of DPR, appraisal of DPRs, and also increasing the testing facilities. Particularly CSMRS had a bottleneck in terms of triaxial testing. So we are trying to see that how that testing facility can be replicated at CSMRS and also at the Institute of National Importance. So 6-7 institutes have come forward, including IIT Roorkee, IIT Delhi, and some other institutes, and they would like these facilities to be installed at their locations. And so we'll see that these locations, these institutes are provided with these facilities with the Government of India funding, and so that the testing, particularly which is taking around 40 to around 2 months time, so that can be fast tracked. So we are trying to see it and trying to tighten all the nut and bolt where we used to take longer time earlier, so that the exercise of preparation of DPR, its appraisal, and also the project way forward, that means implementation of the projects. All these aspects can be expedited so that we realize these projects in 3.5 years to 4 years, or at the most in 5 years time frame. So that's the basic idea. Thank you.
Thank you, Prasadji. Just one more on the supply chain for especially when we are planning to go, and there are a lot of PIL schemes by the Government of India for encouraging manufacturing in India on solar as well as battery energy storage systems. Are we on target for that, or if you could throw some light on that, because there are a number of people who had expressed interest in the private sector in both these, and so if you could throw some light on that aspect.
Yeah, the challenge is to go for a stationary battery energy storage systems, which as Ministry of Power and CA, we have been requesting Government of India. Because earlier, whatever PLI scheme has come, they are targeting towards electric vehicles. And the specifications of electric vehicle and what is required for the power sectors are a bit different. Of course, that can be used, but we don't require that kind of a high density, low space type of a constraint in the power sector. We don't have the constraint of density, nor the space, because this can be installed right at the substation system. Unlike when it is being installed on an electric vehicle, where the weight also matters for the EVs. So we have been in discussion with the suppliers and the manufacturers of battery storage systems, and hopefully we'll get a few manufacturers who will be targeting towards the stand-alone battery energy systems for the power sectors. which can be cheaper than the normal EV batteries as such. Already the cost of BESS has started coming down, and you must have seen that in a number of bids, recent bids. We have given some incentive, VGF, for 13,200 megawatt hour, which is already on the pipeline now. And we are trying to invest as slightly more than 16,000 megawatt hour further to give them VGF to the states, some of the states which wanted this kind of a support. So that this is just to start for, but maybe because of the falling price and reducing price of the BESS, probably it will take off of its own.
Thank you very much, Saji, for sparing your time, for sharing your thoughts, as well as presenting the vision for the power sector in view of Viksit Bharat. So it's a long-term vision up till 2047. I think all the state stakeholders would be very much, would have gained a lot from this vision, and so that they would get a bigger picture of what is really happening behind the scenes in the power sector. Thank you very much, Prasadji, for sparing your time, and thanks very much again. Thank you. Now I'd request Dr. Kirit Parekh, who will be speaking on power technologies for inclusive, sustainable Viksit Bharat. So I'll read out his brief CV. Dr. Kirit S. Parekh is the chairperson of Integrated Research and Action for Development, IRADe, a non-profit think tank that works on policies in the areas of energy, climate change, urban issues, agriculture, and poverty. He was honored with Padma Bhushan, the third highest civilian award by the President of India in March 2009, and shared the Nobel Prize in 2007 given to IPCC authors. He was a member of the Economic Advisory Council of 5 Prime Ministers of India: Atal Bihari Vajpayee, PV Narasimha Rao, Chandrasekhar, BP Singh, and Rajiv Gandhi. He was member of Planning Commission from 2004 to 9, in charge of energy, water, and perspective planning. He was the principal architect of India's official integrated energy policy, and also expert group. Also prepared the expert group report on low carbon strategy for inclusive growth. He is an MTech from IIT Kharagpur, Doctor of Science in Civil Engineering from MIT, USA, and also an SM in Economics from MIT. He's been a professor of economics since 1967, beginning with Indian Statistical Institute in Delhi, and was founder, director, and vice chancellor of Indira Gandhi Institute of Development Research. He was leader of Food and Agriculture Program of International Institute for Applied System Analysis in Vienna for 6 years. He has authored, co-authored, and edited 30 books in the areas of planning, poverty and development, food and agriculture policies, trade modeling, energy modeling and planning, energy policy, energy economics, climate change, inclusive growth, and strategies for low carbon development. So all the ingredients of energy transition, which is required in India and globally. So he's got a huge amount of experience. We would now request Dr. Kirit Parekh to please go ahead and give us address the audience who are here. Thank you, sir. Please go ahead.
Thank you, Mr. Batra, and really Ghanshyam Prasadji, who has given really very detailed and understanding of what kind of technologies and challenges we face. I will have a slightly different viewpoint on this, but more or less consistent with what he was saying. So let me first start with sharing my PowerPoint. I'm going to use that to make it what's happening here.
focus.
Yeah. So,
Yes, we can see it, sir.
yeah, can you see this?
Yes, we can see it.
Challenges that face in this is that it's imperative as India needs to grow. Energy is required for economic growth, and we need to, promote energy efficiency. Clean energy costs more, at least initially, and we need finance. And growing population incomes also require natural resources as land and water. And we need sustainable growth that uses natural resources and energy frugally. And India is highly vulnerable to climate change. A global net zero is required, and India has to attain it too. How do we negotiate this challenge? And how do I go to the next slide? IRADe has explored these challenges using a macroeconomic model. It's a multi-sectoral intertemporal model, selecting alternative technologies for inclusive, sustainable growth and pathways to net zero. Energy efficiency, spread of EV, etc., local air pollution, global carbon space, and India's share in the carbon finance, and how to raise carbon finance. All these have been explored, and IRADe model is econometrically estimated demand system for 10 rural and 10 urban classes in the country. So this accounts for the impact of technology choices on the sectoral structure of the economy and also on the demand for different countries. So it's what people consider as a kind of a feedback is also taken into account. And scenarios maximize present discounted value of household consumption. So this is what we have been doing, and human development and energy access goals for India should be non-negotiable, and that wherever we have, and these are what? Income transfer should be given to eliminate poverty by 2030. Pakka houses for all should be provided by 2025. Sustainable energy for all, or sustainable development for all, target of 1 kilowatt hour per day of electricity by 2015 to all households. The government makes up the deficit in the sense that it's given, but the finance deficit is provided by the government. And cooking gas, we have to give keen cooking fuel to all, at least 6 cylinders of LPG per year, or electric cooking with induction stoves. And quality education, health cover to all should be provided. Now, energy efficiency is very important because, and it has a large impact on power demand. If you look over energy efficiency, it has been has been increasing significantly, and we have used the same kind of thing. We have a number of measures for promoting energy efficiency: LED bulbs, perform, achieve, and trade for industry, SPAT program, appliance labeling, promoting electric vehicles. And I think all these has really made energy efficiency quite achievable. Now, we have made projections to say what will be the impact of energy efficiency on electricity demand, and what will be the impact of electric vehicles on demand, because they will also require electricity for charging batteries. For economy-wide net zero by 2070, we may net to a power sector also zero by actually 2070, 2050. Energy efficiency can reduce demand in 2050, 2060 by 20% or more. And spread of EV needed to reduce petrol products, use charging batteries for EV, which will increase the demand by 20% by 2050 and 30% by 2060, because it will require a lot. It will also change profiles of daily load curves, because what is the time in which batteries are charged and etc. is also all is affected by this thing. And we account for some of these things in our studies. And the question is, could we use new clean coal technologies? Because sustainability requires not only that we provide a clean cooking fuel But also we have to have a clean urban environment. And that is really a part of our inclusive growth, is that urban areas should also be clean. You know, the number of major worst polluted 20 cities in the world, Indian cities occupy half the number of places. So I think it is an important thing that we start. And there are clean coal technologies available, but they all have very high capital costs. And you can see that, you know, they have significantly high capital costs. And if you are also going to use carbon capture and storage, it will require, it's even much more expensive than any of these things. But you can use these technologies to reduce SOx and NOx emissions significantly. But for CO2 reduction, we need CCUS. The problem with CCUS is that it's very expensive. The limited capacity for storing CO2 in the country is there. And this has to be, you know, you have to have this capacity not very far from where your plants are. And environmental concerns are there. Many people worry about the groundwater pollution that impacting CO2 in the ground creates. We need other clean technologies like solar PV, solar thermal, you know, bioenergy with and without storage, both with and without storage, nuclear, hydro pump storage, and off-river pump storage as well. So I think we will examine all this. Now, what we have seen that solar PV has seen drastic reduction in costs over time. And we have used some projections made by many other people also, and assumed our reduction in battery cost following these kind of projections that people have made. And we have taken a slightly conservative rate and so on. We have seen that solar feed-in tariff was 13.5 rupees per kilowatt hour in 2010 when the first set of bids were invited, and it became 2.44 per kilowatt hour in May 2017. Over just a small period of 7 years, we have seen this dramatic fall. And we have used these cost reductions significantly in these things compared, you know, based on projections made by various people. And batteries are also going to come down in their cost. And we have, again, you assume that US dollar, $100 by 2025, and a battery life of 5 years, and the annual operating cost here just to account for battery replacement. This is $100 per kilowatt hour of storage. Balancing power technologies is very critical because, as Mr. Prasad pointed out easily, if you have for non-solar, non-wind hours, what do? Lithium-ion batteries are most commonly suggested. However, we can have a case for stationary storage, other types of batteries which are bulkier and have cost much less and so on. But if you use lithium-ion battery, it will make us dependent on China. And energy security warns us against too much reliance on one source. We have seen Russia turning off gas supply to Europe and US is suddenly raising tariff. This should warn us, and because this can certainly disrupt your economy. And so we should consider other options, more reliable one. Offer your pumped hydro plants is really an important thing. And solar thermal with heat storage, maybe with molten salt storage systems, can also provide another domestic system for storing electricity, which can also provide larger energy security. Coal or nuclear with flexible operation can be done, but they are not very economical because they will, you know, you keep them idle for some time and so on. And, you know, the fuel consumption, etc., go up, etc. Now, we have done a model study in which we show that what is the kind of different technologies are used. This, I'm giving a snapshot of one scenario out of many that we have done, but you can see that subcritical coal, this is generation in billion kilowatt hour in 2070, hardly very little coal takes place. significant gas open cycle gas is certainly used significantly in number. And then we have hydro and pumped storage. Both are really hitting their potential in the country in our scenarios. And then wind onshore goes up, solar PV not much, but solar PV with storage here is really significantly high, and wind offshore is also high, but solar thermal with storage also significant amount develops. So I think you can just see the kind of things that come out. Now, what is interesting to note is, I mean, these numbers can change if you have different cost assumptions and different, so one should have this caveats that these results depend on the assumed costs. Some conclusions, however, we can draw from this. Some coal generation is okay because we will have some carbon sequestration capacity, and if our green area goes, the sequestration capacity will increase. But gas open cycle is used for balancing, but we might want to replace it also. But this is, if gas is also in other uses is replaced, then we have some domestic gas available, and we can use this for balancing, particularly once we have already installed plants. Solar PV with storage will require batteries, and hydro and pumped hydro fully developed, and solar thermal with storage also important. And this is some technology that we should develop it more. We should pay a little more attention for the simple reason that this will give us domestics developed energy security based storage system. The model is a supply availability of different technologies for each hour of different months, and demand and supply are balanced every hour. One can really play with this, make very different scenarios, different kind of things, and see. The demand that we have projected was given exogenously in this model, and this demand is consistent with India's goal of Viksit Bharat, and so on and so forth. So, but all this really poses certain resilience challenges. Energy security, resources concentrated in some states, and balancing national grid without interruptions is a challenge, which requires, as I said, right kind of transmission planning, right kind, reaching every household, 140 million people with energy that provides them access to internet, and that provides them quality education, requires also that we have a really good national and intra-state power systems, as Mr. Ghanshyam Prasadji pointed out. We need also an efficient pricing mechanism to ensure least cost supply, and should be equitable for all states. This is a big challenge because all these energy resources are concentrated in different areas, and redundancies for dealing with sudden failures. This is really very critical, and I think that particularly when we consider that under climate change, extreme events and the frequencies and intensities are increasing. But they may be localized things, but it should be possible to have redundancies so that we can really reach them, and power supplies are not significantly disrupted. These are all known and familiar, but the scale of complexity increases significantly now with lots of renewables and lots of climate change issues with us. Now, but there is one area I want to point out is, climate finance is needed. If you're replacing 1 kilowatt of coal-based power plant, you will need something like 4 kilowatt of solar, because solar generates only, as a plant load factor of 18% or so, and coal as a plant load factor of 80%. So that you really need a lot of capacity, and therefore the investment required upfront would be 4 or 5 times as high as for a coal-based plant. Limiting human-induced global warming to a specific, but what should be climate finance? Keep in mind that it is not the CO2 emissions by a country that causes global warming, but the total cumulative CO2 stock in the atmosphere that adds to global warming. So a country's responsibility depends on its cumulative emissions since 1990. And that's why a global action should minimize cumulative emissions till net zero. Countries should postpone their emissions, encourage negative emissions, equitable burden for all countries, and acceptable to all countries. Burden should depend on responsibility. With this, economists favor carbon tax, that you know. But you can see that different countries, a very different level of carbon tax. And I think with emissions of 4.8 gigaton in 2070, at $50, USA would collect $240 billion if they have a suggested tax of $75 per ton of CO2. Carbon tax, if it is not uniform across all countries, will not be acceptable, because then it will make your relative competitiveness will be affected significantly. So I think what alternative we can think of, that carbon tax or cap and trade has not been accepted as I said, no consensus on allocation of caps. How much I would like to sell all CO2, but how much am I allowed to sell CO2? That is, normally one considers that, okay, it becomes a grandfathering, that whatever you are emitting, that becomes your quota or stock. So I think that is a problem with it. Jyoti Parikh and I had suggested an annual tax of $1 per ton of carbon CO2 parked in the global environmental space since 1990. Our proposal does not require any allocation. It will incentivize countries to postpone emissions and encourage negative emissions. Its acceptability will depend on what is done with the tax revenue. First, we should say, who should we pay? As per the shares in the cumulative emissions 1990 to 2017, USA would pay $147 billion. China, $149 billion. This is the annual payment. And India will pay $33 billion annually. The annual global collection will be more than $700 billion. Those fellows have not, industrialized countries have promised 100 billion, but they have not really met with that target. What to do with the revenue is the question. We suggest that a large part of it, say 80% or more, could be utilized domestically to support ambitious domestic action. A country has to prove that this is the amount of money it has spent on mitigation or on adaptation. And a fixed share should go to the Green Climate Fund for supporting poorer countries for mitigation and loss and damage. A small share should go for local governance to support innovation and to ensure access to technologies to countries for buying patents, for collective action against disaster, for building up global resilience and capacity building in urban agriculture and food sectors. So what is the final conclusion? We say a small parking fee for $1 per ton of CO2 can collect more than 700 billion annually and raise climate finance equitably. It will incentivize countries to postpone emission, promote negative emissions, because negative emissions will reduce their stock and therefore less they have to pay, increase climate action to get more rebate. Accounting for the stock of emissions by all countries is a scientific, fair, and equitable way to ensure action and raise needed climate finance. What about sustainable, inclusive, Viksit Bharat? I believe it's an achievable goal, requires pushing energy efficiency, developing technologies, making policies that are win-win for all stakeholders, and we have suggested some in many areas, and long-term and low-interest climate finance is required. So all this we need, and I hope we can find it somewhere. we can do these things. So thank you all. Any questions?
Thank you, sir. Are there any questions? Because I don't see any in the Q&A box, question answers box, and I also don't see any in the chat. Right. So, would anybody like to ask a question? Please raise your hand so that I can see that, and then I can, maybe I can ask that person to ask the question. I don't see any. Now, just to supplement to what Dr. Kirit Parekh has mentioned, it's Bhutan is doing very well in that, from that point of view. They are already net zero, and they'll continue to be net zero because of the vast. I mean, their source of generation is hydro, almost like 100% hydro, and they've got a large forest cover, a green cover. So they were, I think, net negative. They were net negative emissions. But what they promised is that they will remain carbon neutral for. I mean, that's their target. So Bhutan is doing very well in that aspect. But as Dr. Kirit Parekh said, that people have to be made accountable for the emissions, not only what they're emitting right now, but what they've already emitted, and which has already gone into the atmosphere. And that is where that has to be adopted globally in order to be equitable to people who have already emitted earlier and now are emitting less. So it's they have to be that there's a certain amount which is going to cause climate change, and if people have already done a lot, then they should be accountable for that. And not only what is being emitted presently, but the global emissions which have over so many years from 1990, as Dr. Kirit Parekh said. So let's hope that internationally that is adopted, and then there will be, of course, people who keep emitting. They will also try to stop that because it depends on the global emissions. I mean, the cumulative emissions. But ones who've already done that share of emissions, which are mainly developed countries, should also be held accountable for and pay carbon tax as has been proposed by Dr. Jyoti Parekh and Dr. Kirit Parekh. I think there's one question, which is by Hanuman Ega. Is it possible to supply uninterrupted power supply with these options as we are doing with coal or nuclear? So what I guess he means is the uninterrupted supply using a lot of renewables. Sir?
Yeah, I think it is possible to do that, provided you have, let's say, if you have a pumped storage available, hydro and off-grid, some gas-based open cycle systems and a lot of nuclear power. All these are available. And then I think you can certainly consider a system. And what we have provided is we have really considered really uninterrupted power. The scenario provides for uninterrupted power supply all hours of the month for 12 months, so that you can say about 280 time slices for which we have for each year, the total demand is met. And that is really, I think it's technically possible, certainly. Doing it on ground is, of course, a huge engineering and management challenge. But I think, as somebody had pointed out, how resilient we were when in 2010, or I mean 2020, we had 10 minutes of, or a few minutes of break, total power demand reduction, a large reduction in the country. And then suddenly when it came back, all of it, there was no major disaster of any kind, and the power was brought into it. So I think the engineering and the technical staff has shown the resilience and the skills needed. And I am sure that if we keep this in mind, that this is an issue that we must really deal with, we can do it.
Right. Thank you, sir. Yes, Hanuman, as pointed out by Dr. Kirit Parekh, it's possible to do that using storage, because these are intermittent sources of energy, mainly solar and wind. But to make up for the gaps that these sources are not available, energy needs to be stored. And that's why long duration storage, which you can store energy for maybe 6 hours, 4 hours, 6 hours using pump storage, and more suitably and cheaper method of doing it is closed loop pump storage, which is not river based, but there are a huge amount of interest which has been evinced by the private sector on closed loop pump storage. There is already one existing in Purulia in West Bengal, and there are 2 more stages, Turga and one more, which is coming up in West Bengal. And many states have, many private parties have signed MOUs with the states to bring up this cheap and faster method of storage as compared to river-based pump storage, which are existing mainly in India. There's also the other thing about what will happen if you go close to 100% renewable, that is solar plus wind. What about the inertia? The inertia which was there in coal-based plants, big machines, so the frequency didn't exactly trip immediately. It took some time for the frequency to come down. In the meantime, corrective measures were taken. So you have technical solutions for all these, which is introducing inertia through either synchronous condensers, but even in solar and wind, which are inverter-based, there is a thing known as artificial inertia or synthetic inertia, where you can mimic these plants to be like coal-based plants, where the frequency generation goes down slowly, it doesn't go down immediately while tripping. So there's a prolonged there's a method in which you prolong the tripping so as to imitate these solar and the thermal power plants. So there are technical means to satisfy all these conditions. So that's it. You can of course supply uninterrupted power supply from using solar and wind. And not only that, there is you would have heard of one sun, one world, one grid. The scheme which is proposed by the Prime Minister of India, where you interconnect all the countries in the world, and at some point of time, so the sun will be shining bright in one part of the world, and maybe there's no and it's nighttime in the other side, but it can the solar power from there can flow through transmission system to the other parts where there is where there isn't so not only for solar but for wind also you can transfer this power. So it's using the power resources of this world efficiently so as to make sure that there's uninterrupted power supply. So that's actually cheaper. You require much lesser storage once you interconnect the grids, which so Dr. Kirit Parekh has mentioned about the modeling exercise which was done to make sure, as he said, that every hour you're able to feed the grid using the storage and the existing sources plus storage. Right? Is there anyone? There is one more. Is there? No, there isn't.
Let me add a small note here. that
Yes.
we could run coal-based power plant to up to 50% power factor, load factor, whichever that is possible to do so, but it only increases the specific heat consumption, and it also stresses the plant so that its maintenance cost and lifetime are reduced. So these are expensive, but it's doable.
Right, sir. Thank you. Are there any more questions from anyone, or somebody wants to raise their hand? They can do that. I don't, of course, see any hands raised, and I don't see any open questions now in the Q&A. Thank you very much, sir, for throwing light on various technologies for inclusive and sustainable Viksit Bharat, as well as giving us a brief on the modeling exercise which is done by IRADe to make sure that the power supply, there's power available for all consumers, and even with these with the intermittent renewables, and how we can do it with the minimum cost is what this model did. Thank you very much, and thank you for everyone for attending this. I hope that you've been able to gain insights into how the vision for the power sector and how the country has planned for or the vision that for the power sector that India has, as well as the technologies which are which can be used for going through this energy transition. So thank you very much once again of course, thank you very much to Mr. Ghanshyam Prasad and Dr. Kirit Parikh for sparing their time, for sharing their thoughts on these emerging issues, ones which have a broad impact, and all the issues which power sector is likely to face, and how proposed methods of tackling these. Thank you very much, sir, for your presentation. And thank you to all the participants who have attended this. I hope that there would have been more participants, because these issues are going to affect the globally for many years to come. So these insights will be very useful. Thank you very much, sir, for this.
Thank you all. Thank you.
Thank you to the participants. Right. With that, we'll close.
Bye.
Thank you. Thank you, sir. Thank you.
Thank you. Thank you, Ghanshyam. Thank you.